Hello everyone. In today's lesson we'll be studying differentiation rules. We will be studying the product rule and the quotient rule in differentiation. Here we have a table of some derivative rules that's available in the IB exam booklet. We use the product rule when we have multiplication between functions and the quotient rule when we have division between functions. We will start with this example here. We have a product between two different functions, x squared multiplied by sine x. So before we apply the product rule that's given in the exam, first, it would be wrong to differentiate this function like this, differentiating x squared separately and sine x also alone separately. So it will be wrong to differentiate it like this, y prime, or the derivative will be. We differentiate x squared alone first according to this rule, which becomes 2x, and then we multiply by the derivative of sine x, which is, as we see here, cosine x. So like this, cosine x. Now, as I said, this way of differentiation of the product is wrong, and we cannot apply it at all. So here, to differentiate this function in the correct way, we apply the product rule. So what is the product rule? As you see here, it's given like this, and we can write it in a better way. So if we have a product between two different functions, u times v, then the derivative would be, first, as we see, we have here y prime, or dy over dx, it's equal to u multiplied by dv over dx, which is v prime. So here we have u multiplied by v prime. Then we have here plus the opposite, plus now. We have v multiplied by du over dx, or u prime. So we have v multiplied by u prime. So in other words, we keep the first one as it is, but differentiate the second one, plus we keep the second one and multiply by the derivative of the first one, u. Here, we will apply the first example. We will assume that this is u equals x squared, and this one here is v. So v would be sine x. So first we have to find u prime and v prime. U prime would be the derivative of x squared, which is 2x. And here, v prime would be the derivative of sine, which is, as you see here, cosine x. So now, here we have the four elements that we will substitute here. So the derivative of this function would be y prime equals, first we have u times v prime. So we'll multiply u by v prime. So we will have x squared multiplied by cosine x, plus now here we have the opposite. So here we have v multiplied by u prime. So I will write sine x multiplied by 2x sine x, and for the 2x I can write it before or after the sine. I will write it here before sine. So here we have 2x multiplied by sine x. This is u prime times v. So this is the correct differentiation of this function according to the product rule. We will move on now to this example. Here, as you see, we have multiplication or product between e to the power of 7x and ln 2x plus 1. So we will apply the product rule. But here also, we will apply the chain rule as well that we learned in a previous video. So if you would like to revise the chain rule, you can check the video that appears top right. So here now, I will assume the first one to be u, which is e to the power of 7x, and the second one here, v ln 2x plus 1. So now we will differentiate f prime, or the derivative will be, here we have u as it is, then multiplied by the derivative of v. So we will write here u as it is, then we will differentiate this. U, which is e to the power of 7x, multiplied by v prime. So we will differentiate this v. As we said in that video about the chain rule, to differentiate natural logarithms, first we differentiate the inner function here, 2x plus 1, which is 2, and then we divide by the same inner function as it is, 2x plus 1. Then we have plus, we have here v as it is, so we will write v, which is ln 2x plus 1 as it is, and we multiply by u prime, or the derivative of this u. To differentiate e power of 7x, first, as we learned, we differentiate the power only 7x, and after that we multiply by the same e power of 7x. So this is here all u prime, and this is v here. So this is the derivative of this function. To simplify it more, f prime will be, here we can multiply 2 by e power of 7x, so we will have 2e7x divided by 2x plus 1 as it is, plus, I just here switched between these products, so this is the derivative of this function. Let's now move on to the quotient rule. So here we use the quotient rule when we have division between functions. As you see here, the quotient rule is given in the formula booklet, but I rewrote it here like this. Instead of du over dx, I wrote u prime, and dv over dx is v prime. So if you have division between two functions u and v, then to differentiate that, first we keep v, or the denominator, as it is, and multiply by the derivative of the numerator u. Then we have minus, not plus, as in the product rule. We have here the numerator as it is, multiplied by the derivative of the denominator v, and then we square the denominator here. And then we square the denominator v as it is. So here we will assume that this is u and this is v. So u would be 3x squared plus 11 power of 5, and therefore to differentiate this according to the power rule that we learned in the chain rule video, first we put the 5 down and we decrease the power of the bracket by 1, so it will be, instead of 5 we will have 4, and after that we multiply by the derivative of the inner function, which is here, if we differentiate this, we have 6x. Then if we simplify u prime, we would get, here we have 5 multiplied by 6x, which is 30x, as it is here. Now, for v, we assume the denominator v, which is e power of 3x. Therefore, v prime will be, we will differentiate the power first, 3, and then we multiply by the same a. So this is v prime. Now, we will plug in these into this formula. So the derivative of this function will be equals, here now, first we have v multiplied by u prime. So the denominator v multiplied by this u prime. So we will write, then here we have minus, and then we will do u multiplied by v prime. So we will multiply u here as it is, or the numerator, by v prime. So we will have here e to the power of 3x, all divided by the denominator v squared. So we will square this. We have now e to the power of 3x squared. So this is now the derivative, but we need to simplify it. Here, the derivative f prime can be written like this. First, I will write 30x, then the bracket, and after that a. So here we have 30x minus, here I will write 3 first, then 3x squared plus 11 power of 5, and after that I will write only the e. So we have e power of 3x, and all of that divided by e to the power of 6x. Because here we have two powers, so we simplify this and multiply the powers by each other. 2 multiplied by 3x, which is 6x. Let's now move on to this example. Here again we have division between two functions, so to differentiate this we will apply the quotient rule. Here we'll assume the numerator to be u and the denominator v. So u prime will be the derivative of this. When we differentiate 2x power of 5 we have 10x power of 4 plus when we differentiate x we have 1. V prime now, as you see, when we differentiate cosine, it becomes negative sine. So here, it will become negative sine of the same angle 2x. But after that, according to the chain rule, we differentiate the inner function, which is 2. The derivative of 2x is 2, so we have here 2. So the derivative will be now, first we have the denominator multiplied by the derivative of the numerator. So the denominator here, which is v or cosine 2x, multiplied by u prime or 10x power of 4 plus 1. Then we have here minus u, so minus u, which is the numerator 2x power of 5 plus x, multiplied by v prime, which is this. All of that divided by the square of the denominator, so the square of cosine 2x. So it becomes cosine squared of 2x. Here we have to be careful that when we square the cosine of 2x, it becomes cosine squared of 2x. We never square the inside or the 2x. Now, we can simplify this fraction. So y prime will be, first we have, I will write 10x power of 4 plus 1. Here we have 4. Then we multiply by cosine 2x minus, here we have minus negative 2. That becomes plus now. So I will write this 2 first here, and then 2x power of 5 plus x as it is here, and then we have only sine 2x left. I wrote here the negative 2 with this negative to be positive 2. Then we divide by the denominator cosine squared 2x. So this is the derivative.